Hey guys, so today we're going to be presenting subwoofer placement and effects on frequency response by Patrick Wang
and Francesca Fairman.
So to describe the setup of this experiment, we're taking an SPL meter and connecting it to an audio interface which connects to the computer and outputs a signal to the test sound system. Then the corresponding software, the Room EQ Wizard, will measure the transfer functions of acoustic systems and display the corresponding frequency, phase, and impulse response of the system.
So we began our experiment by calibrating the SPL meter and the audio interface. The top left and bottom right graphs represent the expected frequency response of the outputted calibration test signals, whereas the top right and bottom left graphs represent the actual measured signals. The expected and measured sets of graphs differ by such margins of error due to room reverberation and possible outside environmental noise interference. So this may make our outputted signal slightly skewed.
So for the first part of this experiment, we're setting up the room with two satellite speakers in opposing corners of the room, and then putting the subwoofer in the front right corner of the room. We send out a 0 to 200 Hz test signal, and the frequency response is given in the top right corner. The output of this signal provided the highest gain and the greatest reverberation. So this is an example of how we're doing our experiment. We're going to measure a 256K log sine sweep from 0 to 200 Hz at negative 15 dB for 5.9 seconds. And here's an example of the resulting graph of the frequency response. It might be a little hard to see, but here it is.
So for part B of this test, we use the same setup as in part A, only this time we moved the subwoofer to the front center of the room up against the wall, and this resulted in a middle gain and average reverberation. So for the final part of this test, we placed the subwoofer towards the center of the room at 3 feet from the wall, and this resulted in the lowest gain of the three tests due to the least amount of reverberation.
The results of our experiment can be shown in the following graph, which displays the average of 5 measured values for each tested position in order of highest gain, the subwoofer placement in the front corner of the test room, to the position with the lowest gain, when the subwoofer was placed 3 feet towards the center of the room. Although there are multiple reasons for the results in this experiment, a prominent cause could be due to the effects of reverberation and a signal processing phenomenon known as comb filtering. Comb filtering, if you don't remember, is when a delayed version of a signal is added to the original signal through such events as reverberation. Using superposition, the newly constructed signal will look like a comb with a series of regularly spaced spikes because of constructive and destructive interference. By looking at the resulting graphs, you shall see just that, mostly evenly spaced spikes at varying frequency values. By varying the distance of the placement of a subwoofer or any loudspeaker from a surface with a high reflection coefficient, you can adjust the amount of reverberation and, in effect, the amount of gain achieved through comb filtering. For the highest possible gain from the lowest input signal, placing a subwoofer or speaker against a corner would be ideal because it provides 3 walls for the original sound source to reverberate against, the floor and the 2 intersecting walls. While in contrast, if slight or no additional gain is required, then placing the loudspeaker more towards the center of the room away from the walls would be the most ideal. And that is the results of our experiment.
So this concludes our project. We hope you enjoyed it.